It's question 29 here on Wagner Academy for the SAT Math questions. It says if W is the set of all integers greater than 2.1, so before I move on, I'm going to draw a picture of that on number line of that. So here's W. Here's a number line of W. This is all integers greater than 2.1. So if I've got, this would be 0, let's say, this would be 1 and 2. So is 2.1 an integer? No, it's not an integer. It's a set of all integers greater than that. So here's 3, 4, 5, 6, 7, and so on. So I'm saying any integer that's greater than 2.1. So 3 would work. 3 is an integer. 4 is an integer. Remember, integers are just, it's kind of like the positive and negative whole numbers. That's the way I tend to think about it. Plus 0, including 0 as well. So it'd be this, and this pattern would continue. So I'm going to put a dot, dot, dot above the number line right there. 8, 9, 10. All those would be included as well. And now x is a set of all integers less than 2.1 squared. So here would be x, and this is less than now, and it's still integers. Well, we need to know what 2.1 squared is. That one I don't have memorized. If I knew what 21 squared was, then I could just move the decimal a couple places over, but frankly I forgot. Okay, 4.41, that's right. 21 squared is 441. So I have here, if I do the same number line, might as well. That'll help for comparison, make it really easy to compare. 0, 1, 2, 3, 4, 5, 6, and 7, and it would keep going on and on forever in both directions there. But set of all integers less than 2.1 squared. 2.1 squared, we just said, was equal to 4.41. So the first integer that would be less than that would be 4. And then we would continue in the other direction, going this way, forever and ever and ever. So again, I'm going to do the dot, dot, dot thing there. So what do they have in common? In other words, how many integers are in both sets? That's what the question is asking us here. And so I see that this one, excuse me, my voice, yes, it just cracked. I don't know why. I've definitely hit puberty a long time ago. So we have 3, we have 4. Those are the only 2 integers that are in both sets. So how many integers is that? How many integers are there in both sets? That would clearly be choice B. 2 integers in both sets.